Hello, this is Pooja from 9th at Narayana SMPS campus. So today the concept we are going to discuss is circular motion. So does this object look familiar to something to you? Maybe you can be seeing this object and played with it definitely. So do you wonder that you can learn a topic with this object? So today I'm going to explain you a topic with this kind of object with the help of this object. So now without any delay, let's dive into the topic. Okay. Now our first topic is, for example, a person who is standing here and rotating an object above his head. So for example, that object is here. The velocity of this object directs in this way, means tangential direction. If the object is here, then the velocity directs in this way. So at different positions, at the respective its time, the velocity changes. So if an object changes velocity in respect of its time, it is known as acceleration. That something can exact in this way is if some sort of net force acting on that. So if the object which is having some certain velocity and experiencing a force is called centripetal force. So so in this direction, the centripetal force is active. So every time the centripetal force always points to the center. The formula of centripetal force is F subscript C is equals to mv square by r. So now let's see the derivation of this mv square by r. So we already know that F is equals to m into a and a is equals to v minus 2 by t. So where u is equals to 0, it becomes a is equals to v by t. So v is equals to r by t, radius by time, and t is equals to r by v. So now let's come here. So F is equals to m into, already we know that a is equals to v by t, and where t is equals to r by v, so that is equals to m into v by r by v. If we transfer this v here, it becomes m into v by r. So that is equals to mv square by r. So this is the derivation of the formula of centripetal force. So now let's go on to our next topic. Before going to the topic, let's know about tension. Tension means stiffness of the string. Now let's know it with an example. For example, I am pulling a bucket from the well where I exert some upward force on the bucket. So that force is called tension. So at the highest point, for example, I have some pendulum. If I keep the object here, it just falls down. It doesn't stand stiff here. Means the tensional force is 0. So now let's look at our next topic. And our next topic is minimum velocity for an object which is needed to come to the highest point. So, for example, if a man is standing here and he starts from 0 degrees, he starts rotation from 0 degrees, it comes to 90 degrees, 180 degrees, 270 degrees, and at last 360 degrees. For example, if the object is here, we will note it as P. If the point P, at this point P, this object makes an angle theta here. And here already we discussed that centripetal force and tension acts in this direction. So, and here gravitational mg acts vertically downward, which can be divided into two components, which is mg cos theta in the radial direction and mg sin theta perpendicular to it. So, if we have to know that the centripetal force which is exerting on this or at this string, so we have the net force acting at this point is T minus mg cos theta, which is f subscript c, self-repeated force. But also we derived it as mv square by r. F subscript c is equals to mv square by r. So by this we can say that mv square by r equals to t minus mg cos theta. So already if we send this minus mg cos theta, it becomes plus at this end. At that time it becomes mv square by r plus mg cos theta. So already we discussed that. Now the topic we are discussing is the velocity needed for an object to come until the highest point. Already also we discussed that at the highest point tension is 0. So 0 is equals to mv square by r plus mg cos theta. So here I want to take 0 is equals to mv square by r plus mg cos theta is 180 degrees. Because here mv square by r is centripetal force which is acting in this direction. And mg cos theta is 30 degrees. So these two forms an angle 180 degrees here. So as that we took 180 degrees here. So if we send it becomes 0 is equals to mv square by r plus mg. If we send this mg here, it becomes minus mg, that is equals to mv square by r. Where mm gets cancelled and if r transfers here, it becomes gr, and that is equals to v is equals to root gr. So this is the velocity needed for an object to come from 0 degrees to 180 degrees. Means from lowest point to highest point. So now let's look at the next topic is, now we discussed that from 0 degrees to 180 degrees. Now we are going to discuss this from 0 degrees to 360 degrees. Means an object which needs the velocity to complete the rotation. So let's look into that. We already discussed that. So tension in a circular path in the string acts perpendicular to the displacement of the ball. So here hence T is equals to 0. So the mechanical energy is conserved in the gravitational field. So here for example, I took a pendulum and this is the center which the axis is. And if I rotate this from this point to this point, at the highest point, the complete energy is, at the highest point, kinetic energy plus potential energy, that is equals to half mv square plus mgh. So, after completing the rotation, if that ball comes again to this place, and at the lowest point, the kinetic energy is, half mv naught square. So here the height h is 2r. So as I already told you, at this highest point tension is 0 and the mechanical energy is conserved in the gravitational energy. So by applying the law of mechanical energy, conservation of mechanical energy, we write that half mv naught square is equals to half mv square plus mg into 2r, because the height is 2r. So half mv naught square equals to half mv. We already proved that v is equals to root gr. So root gr whole square plus mg into 2r. So the root and square gets cancelled, and if we take common at m, it gets cancelled. So if we multiply this, v naught square by 2, that is equals to half gr plus 2gr. If we do cross multiplication, we get v naught square by 2, that is equals to 5gr by 2. So 2 gets cancelled. So v naught is equals to root 5gr. So finally, the velocity needed for a ball to complete the rotation is root 5gr. So thank you. I am so thankful for my physics teacher, Mr. Hariprasad sir, who gave me this opportunity. Thank you.